Hello everyone, good morning. Today we are going to discuss about what is partition and what is file system. So before we are getting into the uh, uh, Windows administration part, means installation, setup, configuration and all, we should know what is partition and what is the file system. Okay, so let let's see what is partition. What is partition? Can anyone know what is partition? Can anyone know? Okay. So partition, disk partitioning or a disk slicing. Why we need a disk partition? First, what is the partition? Partition is nothing but so slicing the disk into multiple parts, multiple partitions. So let's see, this is the disk. Okay, disk 500 GB. Okay, disk is 500 GB. This is 500 GB disk. So slicing the disk into multiple partitions. So let's see, this is one partition. Yeah. One second. Mm, okay. Okay. There is a issue. Okay. This is one partition and this is one more partition. And so we can divide into or slicing or dividing, whatever we can call it. Dividing into multiple partitions is called disk partitioning. Disk partitioning is a method, is a process of slicing or dividing the disk into multiple partitions. So this is one partition, P1, partition 1, okay? And this is partition 2, partition 3, partition 4, partition 5. So we can make the partitions like this, okay? But each partition has a some size, right? Yeah, all I just gave the generic name. Okay, partition 4, partition 5. Okay, so each partition, this is one partition, this is second partition 2, partition 3, 4, 5. Each partition has some space. Like, so this is total disk size is 500 GB. So I'm just giving 50 GB space to partition 1. So while dividing or slicing the partition, we can allocate or we can assign some disk space to partition. So I gave 100 GB to this, sorry, yeah, 100 GB. Okay, and this I assign 100 GB. I'll let you know how to divide this, divide the disk into partitions and assigning the space. I will let you know in the upcoming classes. This is the only theory class. Okay, how we are going to create multiple partitions and dividing a multiple partitions or slicing the multiple partitions in a disk, and how can we assign space to that partition and all we'll discuss in upcoming classes, so don't worry. So the total of 500 GB, I divide or sliced into 5 partition, and each partition having see this partition 150 GB and partition 200 GB, partition 300 GB, partition 400 GB, partition 500 GB. So what is the leftover? 50 GB, right? So this is called unallocated space. If you don't partition, if you don't divide partition, then we can call unallocated space. We can call unallocated space. This is called unallocated space. So if you don't perform or divide the partition, if you don't slice or divide the disk, then we can see that space called unallocated space. If you perform or perform the partition, so you can see the partitions. If you don't divide the partition, if you don't divide the partition, we can see unallocated space. Okay, so unallocated space is 50 GB. Sorry, 50 GB. This is how usually we see in the disk. So fine, why we need to do partitions? Can't we use a single part? Can't we use a disk, a single partition? Okay, I want to do a single partition. P1, 500 GB. So all 500 GB, I can make one partition. So we can do that. But why we need uh, multiple partitions? As you said, we can create one partition in all hard disk. Then it's a fine. It's a good and less work. You no need to slicing the disk into multiple parts and assigning the space, each partition to 100 GB or 50 GB or 200 GB. It is a headache. Why you need to, yeah, 50 GB. Why we need to do multiple partitions? So I'll give you an example here. We have a house. So everyone, I think, own house or rented a house. Can we made house a single room? No bedroom, no bathroom, no hall, no kitchen, nothing. Can we use without all these partitions? Can we use a home? Then that will not be a home. That is a room. Even no one will stay in that, because partitions is nothing but in the home. Coming to a home, it's a privacy. Data, I mean, it's a privacy at the same time, and security and segregation of our work. See, we cannot perform cooking in a bedroom, right? We can, the segregation of work, watching TV, cooking food, sleeping, and lot of activities we do on our day-to-day basis on it, right? So all these activities we segregated coming to home. So when we cook food, we go to kitchen and cook food. When you want to sleep, you want your you want you go to bedroom and sleep. And you want to watch TV, you go to hall and watch TV, right? So that is segregation of work, so that our life will go smooth. If you segregate your work in a different places, so that your life will be go smooth. Same, likewise, same. Take the example here. If you take one partition and putting all the data in the partition, in this partition, like Windows, Windows OS, and user data, and programs, services, and database, so on. So and so on. Okay, so all the work if you've done in a one partition, there is no segregation. If you don't segregate the data, for example, the OS got crashed. This got crashed. So what will happen? The system cannot boot. So hence, if the OS is got crashed, then the system cannot boot. So what will happen? You cannot access user data, program data, services database until unless you fix the OS issue. And if there is a chances, if there is a situation to format the OS or repair the OS or restore the OS. So the way of the situations in the process of fixing the operating system, you need to restore or format and reinstall or repair. So if you want to perform an activity to restore the OS, to repair the OS, then there are chances to lose the data. There are chances to lose your data. So if you format, what will happen? The entire partition will be formatted and all the data will be erased. So data loss. So coming to this scenario, so I install OS here, Windows OS. Okay. So for example, here OS got crashed out. Okay, what will happen? I can simply format this partition because see, I have a data here, user data here. I have softwares, programs installed, programs here, database here, and services, so on, many services. So there are no way to lose our data because the OS is in partition 1. I can repair it by reinstalling the OS or repairing or formatting the OS and reinstalling the OS. So whatever I do, that will that activity will be on partition 1 only. The rest of partition will be safe because here we segregate the activities data into multiple partitions. Please mute yourself. Okay, and because of guys, please mute your. Okay, because of segregation, because of data segregation, activity segregation, we will be in a safe mode. When something happen, our nothing will happen to our data. Okay, this is the one reason why we need why we create partitions into disks. And second one is, if you create a big partition like 500 GB, one single partition, the memory allocation will be in a different. For example, memory blocks. So how the memory will store? In memory blocks, right? So this is a hardware thing. So our data will stored in memory blocks. So if you create a big size partition like 500 GB, one single partition, in hard disk, memory blocks will be created big size blocks, like for example, 5 MB. It's a just example. It's a just example. Let's say the memory block is created with 5 MB. So this is multiple memory blocks in 500 GB. So 500 MB memory block created. So like 500 MB, sorry, like 5 MB, the many thousands of memory blocks will be created in the hard disk. This is the hardware part. Let's say this is an example. It's not exactly 5 MB. I'm just giving an example, let's say. Because it's a big partition, memory block got created in MB, 5 MB. Okay. So here what will happen? Because it is a small partition. So here memory block will be 1 KB. 1 KB. Okay, 1 KB. So it's a good, right? Why just highlighting that 5 MB is bad and 1 MB is good? So let's see. For example, our data is storing. I have a data called 4. I have a data called, let's see here. Let's see here, MB. That's just to make you understand. See, 1 MB. Let's take 2 MB. Okay. So here the MB, the memory block size 2 MB, and here not MB, usually KB. It's okay, KB. 2 KB, here 5 KB. So I have a data 1.5 KB. 1 KB, 1.5 KB files are more in my data. 1.5 KB. So here 1.5 KB will fit into this, right? So 0.5 KB going to be wasted here. Here, how much? Same data. So 1.5 KB files will be stored 3 files. Okay. And 0.5 KB will be wasted, right? Here, same. For example, here 1.2, 1.3 KB files. 1.3 KB files or 2 KB files. 2 KB files. There are many 2 KB files. So what will happen here? 1 KB will be lost. So the memory block size, what I'm trying to say, if memory block size is big and file size will be small, then the more memory will be wasted in this. So 2 KB, 2 files, 1 KB will be wasted. So if you create a bigger partitions, what will happen? The memory wastage will be more. If you create a smaller partition, the memory wastage will be less when compared to this. So that is also one of the reason to create a small partitions instead of creating a big partitions. So in the real time, we see 1 TB, 500 GB, and many big partitions. Yes, coming to database and big servers where the file size will be in GBs, file size will be in GBs. There, the data will not be get wasted. I mean, memory will not get wasted. So where the small size files will be there, the data will be, memory will be got wasted. So that is the reason we create a small partitions. For example, in your data, you have a small size of files like 1 KB files, 2 KB files. Then you have to create a small partition. If your data is bigger, like data will be in a GBs, then the memory will not get wasted. Okay, so that is based on our data, the memory blocks will be wasted. And coming to how the memory will store in the hard disk. So the data will store in hard disk in circles. So hope you're see the CD DVD drive, right? Similarly, data will be stored in circles. You can find the circles in CD DVD drives. The data will be stored in CD DVD drives. This is circles. Here the data will store in the hard disk. Okay. One moment. I have a Linux. Okay, no problem. Data stores in hard disk. Yeah. So this is, if you see, this is called tracks. What are the circles I said? These are the tracks. In the tracks, data will be stored. Sectors. What sector? Each track divided into multiple sectors. So this is the track, right? So let me divide into tracks. This is one track. This is called sector. Sorry. How the data store in the memory in the hard disk? This is sector. This is called sector. And this is called tracks. But in a layman language, we call circles, right? But this is tracks. We call tracks. So each track divided into multiple sectors. So the data will be stored in tracks, sectors. Each sector having 512 bytes. So each sector size will be 512 bytes. So our data will be stored in sectors. So each track divided into multiple sectors. Each sector can accommodate 512 bytes data. So the data will be stored in the tracks and sectors. This is a hardware. I would like to tell you this so that how the data will be stored in hard disk. Okay. Hope you are clear. So for example, if you see the CD and DVD, you can see the tracks. In the tracks, you can see the sectors also. So in sector, data will be stored. Okay. That is a backend. How the data is storing in the memory, in the hard disk. In the hard disk. So coming to P1, P2, P3, P4, P5, there are multiple partitions we can create in a single disk. Okay. So each disk by default naming with alphabets like C drive. So why it is starting C drive? Because A drive, B drive will be reserved. Will be reserved. So those will not be allocated to any partition. Why? A drive uses floppy disk. So why A and B drives reserved means, yeah, means A drive uses hard disk. Sorry, floppy drive. So I think now this generation doesn't know what is floppy disk. Floppy disk, like a CD, before the CD, we carry 144 MB, almost 144 MB data we used to carry in floppy disks before CD generation. I think 90s, who born in 80s, they might know what is floppy disk, how the floppy disk looks like. So this is the floppy. This is So we can store 144 MB, I think, data we can store in the floppy disk. So earlier we used to store the data into floppy disk uh, to carry the data from one place to another place, like CDs, pen drives. Okay. So the system reserved drive A and B, drive A and B for floppy disk. So actually A and B are reserved the system partitions on earlier, which were reserved for floppy disk. So that is the reason Windows is giving partition name from C. From C. So C to D, usually Windows follow the sequence C drive, D drive, E drive, F drive. But can we change the drive name? Yes, you can change if you want, or else Windows giving in a sequence order. In a sequence order. C, D, E, F, G. Okay. Windows used to give a part drive letter. This is called, we call drive. Then the partition become a drive when the Windows assign the name like C drive, D drive, E drive, F drive. We call this is drives. Then we call drives. See, now the partition become a drive now. When after formatting the partition and assigning the drive and file system, that become a drive. The partition become a drive. Okay. Coming to what is file system. Can anyone tell me what is file system? Can anyone know what is file system? Okay, no problem. So file system is a method. File system is a method to storing the data in an organized fashion on the disk. Every partition on the disk except MBR and extended partition should be assigned with some file systems in order to make store them the data. File systems is applied on the partition by formatting it with a particular type of file system. So for example, why we need a file system? File system is a method of storing data in organized fashion. For example, go back to our home example. So in your home, if your things organized or if you put your things in the home in an organized manner, then what will happen? Whenever you want, you can quickly pick the things, because it is an organized fashion, all the things in a proper sequence or proper way. If you put the things in your home, if you don't put the things in an organized manner, what will happen? In a more space, less items will be occupied. So if you put the things in organized fashion, in a less space, more things will be fit into your house, right? So likewise, in the disk, this is a hard disk. Okay, in the disk, if you put the data, if you store the data in organized fashion, what will happen? What will happen? The data, one second, I'll, oh, one moment. Okay, let me take 2 hard disks. One is with file system, and another one is without the file system. So both are hard disks. Let's say it's a 100 GB hard disk. Okay, so one disk is with file system, another disk is without the file system. Let's see how how data will store without the file system and with file system. Okay, I'll give you a visual example. Okay, so with file system, the data will be stored in a organized manner. Okay, in a one second. See how the data is uh, storing in an organized manner. Let's see how the data will store uh, in a disk without the file system. Which disk doesn't have a file system? How the data will store? Let's see. See, this is how data will. So what you observe here in both places, if the data is stored in organized manner in the hard disk, what will happen? The read write speed will be more, and more data occupies less disk space. Here, more disk space occupies less data. So, and reading and writing speed is also very slow here, because if the data is in organized fashion, you can quickly read and write. But here, if the data, if you want to read and write the data in this disk, it is very tough because data is not an organized fashion. If your things in a keep in organized fashion in your home, you can quickly pick the bike keys, car keys, whatever you keep in your home, you can quickly re catch the things, because the things are in organized manner, so that you can quickly grab the things whenever you want. But in without, if you're not things keep the things properly in your home, you will search things for every time, right? So this is a without file system, with file system. If the disk doesn't have a file system, data will be stored in an unorganized fashion. If the disk having a file system, the data will be stored in an organized fashion. Okay, so Now we came to know what is file system. Now let's see what are the file systems for the Windows server. So FAT16, FAT32, there are two file systems. These are very old. We are not using at all. Now, this is file allocation table. FAT means file allocation table. So the FAT file systems are not, uh, not I think using anywhere. Now NTFS. NTFS is new technology file system. It is a file system which we are using currently. And REFS, resilient file system, this is also we are using. So now these two file systems are using in the Windows operating system. And earlier we used FAT16, FAT32 in the old Windows operating systems. Okay. And also if you have a old pen drive, I mean, that we call flash drive. Flash drive, there we can see the FAT file system in that flash drive. So where we can see the file system, see if you see here, right click on a partition, see file system NTFS. You can see the file system, which file system was assigned to the disk. You can see here NTFS. So that is the reason while before installing the operating system into the computer, in computer's hard disk, what the operating system do? First, operating system format the hard disk. Formatting, cleaning the hard disk. Formatting is nothing but cleaning the hard disk. Any bad sectors, any bad things, it will erase and assign the file system. So before OS landing, the OS will format the disk or partition and assigning file system. Then only Windows will start installing into your disk or a partition. Otherwise, Windows will not install, because without the file system, Windows cannot install. Not only Windows, any operating system like Linux, Unix, Mac, anything without the file system, no operating system will run in the disk. Okay. Yeah. Coming to, we'll discuss more in detail in upcoming classes about the file systems. Okay. Okay. In Windows, Microsoft usually releases two types of operating system. One is client operating system and second one is server operating system. So why the Microsoft releasing two operating systems? Okay. So as we discussed in the demo class, what is server and what is client? So because of, if you want to publish services, if you want to provide a services to other systems in the network, we use server operating system. If you don't want to provide any services to any systems or users in the network, we can use client operating system. And the client operating system is the platform to access remote services. For example, Google is a remote service, right? Google is a remote service. So to access this service, you should have a operating system, right? Without the operating system, can we access Google? No. If you want to access a mobile, you need Android OS. If you want to access a system, you should have a Windows OS or a Linux or anything. Some platform should be needed to access remote services. So coming to Windows, they developed a operating system called client operating system. So to access remote services, server operating system to provide the services. For example, if you want to provide a search engine like Google, like Googly, so you need to install that Googly search engine in one of the server operating system. So for publishing the services, Facebook is a website. So they install the Facebook or deploy the Facebook in one of the server operating system. Then only we are able to access. So to install, to deploy services need a server operating system. So that is the reason Microsoft developing server operating system and client operating systems, both. So coming to server operating system, we all know Windows 95 is a very old operating system. I think most of you guys doesn't have any idea about Windows 95, I feel, because it's very old operating system. 95, 98, XP, Vista, 7, 10, 11, so on. And server operating system. Windows NT 2000, 2003, 8, 12, 16, 19, 20, 22. So these are all the server operating system. So our course mainly focused on server operating system. So our course completely on server operating system. So because in the server operating system, we create many services. We create many services. I mean, we create, configure, install services in server operating system. So in client operating systems is only to access those services. Okay. So coming to types of OS editions. Usually, sorry. So, and one more thing before getting into the editions, why the Microsoft keep releasing the operating systems? Do you have any idea about why? Okay. So based on the current technology and current users requirement, based on our requirement, Microsoft keep developing the new versions for the current situations requirement. The current situations requirement, as per the current situations requirement, Microsoft developing a new operating system. What are the present scenarios? What are the company's requirement? And what are the projects requirement? So based on the requirement, Windows keep developing operating systems and releasing ever by year. I mean, every year or by year. Okay. So and challenges, and also it includes challenges, hardware challenges, compatibility challenges, because if any software doesn't install on the Windows operating system, for example, let's say one, so that will affect the business, Microsoft business. So make sure that Microsoft uh, uh, developing a operating system with all the software's compatibility and current scenarios challenges and hardware challenges, software challenges, and requirements, and our requirements, business requirements. Yes, that is the exact word, is business requirements. So based on all scenarios, the Microsoft developing operating systems and releasing to the market. And before, so Microsoft is a paid operating system. It is not free operating system. It is not open source. It is not open source and it is not free. So there are two differences, free and open source. So free means the software is free to public. So anyone can use the software. And what is open source? So most of the people are getting confused between free and open source, right? Free is nothing but it is a free license giving to the public. So anyone can use the anyone can use the software, either it is operating system or any software can use free without paying single NB. So we can download from the internet. Who are providing the free software, they will have a website. So they will allow public to use the software or operating system without paying single NP. That is called free. And open source. Open source is nothing but if the same software is giving a code to the same, for example, let me give you an example. So X is a software, like X is a software, and ABC is a company. ABC is a company. Okay, the ABC's company developed X software and giving to the public for free. Okay, this is called free. Free. But what about open source? It's not open source. See, it is not open source, but it is free. What is open source? Open source. It is not a open source. What is open source? Open source, if the ABC company publishing the X software code, if the ABC company provide X software coding, complete coding, make it available on the public network. Okay, making code of X software no, publishing the code of X software on the internet. This is called open source. Open source is nothing but you are revealing the code, you are publishing the X software code on the internet. So anyone can take the code and improve the X software and republish the software XX. For example, me, Anand, I took this code. Okay, I downloaded the X software code. Okay, and added few more features to the X software. Okay, I added few more because the code is available on the internet. So I modified the code and enhanced the code. Okay, enhanced or added and modified based on my requirement, my current organization requirement. So I enhanced the code and added, modified, and deleted code of X software and published published Anand software. So this is called open source. Free is different, open source is different. So free is nothing but just giving the software to you to use. That's it. They will not publish their software code on the internet. Open source is nothing but they're also giving a free software along with you can edit the code as well. That is called open source. Open source, you can download the code of the software and you can add, edit, modify, and you can create your as per your requirement, you can create one more software based on the this code. That is called open source. So coming to Windows, Windows is not open source and it is not free. It is a paid operating system. It is a paid operating system. You have to pay and take the operating system. So, so that is the reason Microsoft releases the operating system in editions: Standard Edition, Enterprise Edition, Data Center Edition. So if you go shopping, you will see different sizes: S, L, M, small, medium, large. Shirts are so because based on our size, we'll choose the clothes, right? Likewise, Windows Microsoft releases 3 editions: operating system, standard, especially these editions mostly for Windows Server operating systems. They will give the same operating system. Operating system will be the same, but they will release in editions: Standard Edition, Enterprise Edition, Data Center Edition. Why they are releasing in editions? The same operating system, but in a different editions: Standard Edition, Enterprise Edition, Data Center Edition. So why the Standard Edition? Means, see, because based on the editions, they will charge. Based on the editions, they will charge. So who will fit for Standard Edition, Enterprise Edition, Data Center Edition? For example, this is the example data. This is the example data. For example, Standard Edition, in Standard Edition, Windows Standard Edition, this Standard Edition supports 10 GB RAM. Just its example. And 1 TB hard disk. In Enterprise Edition, RAM will be support till up to 20 GB. And disk will support up to 10 TB. And Data Center Edition, RAM support in this operating system, Data Center Edition, RAM will support 40 GB and disk will be 100 TB disk. Just this is an example data. This is an example data I'm giving here. This is not accurate. This is just example. So the companies will choose the operating system based on their requirement. For example, a small mid-range companies usually take Standard Editions because they're having a less projects and less not high scale projects. They're a low scale, medium range scale projects. So for that projects, Standard Edition is enough. They don't need Enterprise Edition because cost may vary. So less cost, okay, less cost. This is high cost. And it is too high cost. Too high. Okay. So based on the cost and not requirement. So the Windows Standard Editions, the Windows Standard Edition is the server operating system that allows a computer to handle network roles such as web servers, domain controllers, printers, and file servers. It is the most popular edition for Windows Server and suitable for small to medium-sized business. See, for why the medium sized small size? Because they're having a medium less small scale projects. So for the small scale projects, they need, for example, one of the project need a file server. So if the project is small or medium, obviously the data will be less, right? So domain controllers. So based on the business, based on their business, the companies choose editions. Even sometimes small companies may get large projects, large scale projects. Then they have to choose enterprise because the large scale projects needs more data, more processing, data processing. mode. So for that, they need more memory compatibilities, hard disk compatibility, memory compatibility. So that is the reason companies choose based on their projects. So Windows Enterprise Edition. Windows Enterprise Edition is good choice for companies that plan scale in the near future. It supports 524 petabytes, the maximum amount of RAM. See, 524 petabytes RAM, and the maximum number of core processors that the host system offer, compared to the standard 128. See, standard edition only up to 128 GB. 128 GB RAM supports. But here 512, 524 petabytes, 524 PB, petabytes. So the enterprise edition is focused on servers that requires a large scale processing and memory compatibilities. So the same OS operating system will not change anything. The same operating system, but the hardware compatibility is a difference between standard and enterprise and data center edition. Okay. So as well as a cluster and Active Directory federation services. So Windows Server Data Center Edition. Windows Server Data Center Edition is the Microsoft most powerful server operating system designed for business that requires high level of scalability and virtualization. It is optimized for the large data warehouses, server consolidation, OLTP online transaction process, and line of business applications. High scale like Amazon.com, thousands, lakhs of transactions. So if you take any Google, Facebook, Twitter, Instagram, so there are lakhs of not thousands and lakhs of transactions, lakhs of requests. So which we can handle by Windows, which handled by Windows Server Data Edition, Data Center Edition. So these editions will be chosen based on a company requirements. So why here small companies we quoted here? Because usually small companies will get small projects. Enterprise companies will get enterprise large scale projects. And data center editions usually uses in cloud and data centers, because in the data centers, only one single mission having a multiple services. So that is the reason this data center edition uses like data centers, cloud, Azure cloud, AWS cloud. See, these are all editions based on our services. If your service having a large number of audience and large um, scale, you need to choose data center edition and enterprise edition. If less, you need to choose standard edition. So read the theory for more info. Okay, coming to the measurement, the units of measurement for computer memory, how the computer memory will be measured are based on multiples of based on units. So here the computer memory measure like the below. Okay, let's see. One bit is equal to binary digits. One bit having binary digits, zeros. These are the binary digits. Okay, and 8 bits is equal to 1 byte. 1 second is equal to and 1024 bytes is equal to 1 kilobyte. We call KB. 1024 kilobytes is equal to 1 megabyte, MB. 1024 megabytes is equal to 1 GB, gigabyte. 1024 gigabyte is equal to 1 terabyte TB. 1024 terabyte is equal to 1 petabyte PB. Okay. And 1024 petabyte is equal to 1 hexabyte EB. 1024 exabytes is equal to 1 zettabyte ZB. 1024 zettabyte is equal to 1 yottabyte YB. 1024 yottabyte is equal to 1 brontobyte BB. 1024 brontobytes is equal to 1 geobyte GB. 1 geobyte. So this is how we are measuring the computer memory and data as well. So we measure data and memory based on this. Especially, I'm just giving the memory, how we are measuring the memory, computer memory in the like below. Okay. So that's all for today. Any questions? Any questions, guys? Yes, tell me. Okay. No questions? Okay. Thank you all. Thanks for joining. Have a great day. See you tomorrow at the same time.